Have you ever seen old gates covered in reddish flakes like this? Silver spoons that have turned black, or copper vessels like these that have lost their shine and turned greenish here and there. Why does this happen? The answer lies in a slow and sneaky process called corrosion. Now, what is corrosion? Corrosion is the process in which metal slowly gets eaten away by the action of air, water, acids, or other chemicals present around them. It weakens metal and spoils their appearance, just like the nail that you are seeing here. Now, let's look at some real life examples of corrosion around us. Silver spoon is a very good example which turns black when exposed to air for a long time. This happens because silver reacts with hydrogen sulfide, that's a chemical compound present in air, to form a black coating as you see here of silver sulfide, that is Ag2S. Now let's look at the chemical reaction. What's happening here? That is 2Ag silver plus H2S, that is hydrogen sulfide, react to form Ag2S, that is silver sulfide, that's the black substance that you see there, plus H2, that is hydrogen. Right? So this is how corrosion takes place with silver articles. Now if we move on to iron, iron reacts with moist air to form a reddish brown deposit as you see here on this chain, which is called rust. Rust is hydrated iron 3 oxide. Right? What is the chemical reaction happening here? The chemical reaction happening here is pretty simple. That is 4Fe, that is iron, plus O2, that is oxygen, and water, that is H2O, react to form 4FeOH thrice, that is iron hydroxide. When this dries, it forms Fe2O3.H2O, the familiar flaky rust we see on the old iron bars and vehicles. That is hydrated iron oxide. That Fe2O3.H2O is the hydrated iron oxide. Now moving on to copper. When copper objects like these utensils or even the Statue of Liberty, when it's exposed to air and moisture, they develop a greenish layer of copper carbonate. This layer forms due to a reaction between copper, carbon dioxide, water and oxygen from air. Let's look at the chemical reaction here. 2Cu, that is copper, reacts with H2O, that is water, and carbon dioxide, that is CO2, and O2, that is oxygen, to give CuOH twice, that is copper hydroxide, and CuCO3, that is copper carbonate. This copper carbonate is what you see as the green coating over the copper articles. This process is called patination of copper, and that's why this Statue of Liberty made that more than 300 years ago has turned green. It looks green now. It's not looking anymore in copper color, right? And finally, let's look at aluminium. Aluminium, we all know aluminium, when exposed to air, forms a thin protective coating of aluminium oxide on its surface. Why it's called protective coating? Because this layer actually prevents further corrosion. So sometimes corrosion is useful as well, right? Let's look at the chemical reaction. That is 4Al, that's aluminium, reacts with 3O2, that is oxygen, to give 2Al2O3, that is aluminium oxide, which is the layer that is forming over the surface of aluminium. See, corrosion not only damages objects, but also causes huge financial loss every year. Iron bridges, pipelines, and ships get corroded and requires maintenance, regular maintenance because of it. On the other hand, metals like gold and platinum do not corrode at all. They always glitter. That's why they are called noble metals. So next time you see a rusted iron gate, a blackened silver article, or a green copper utensil, remember, it's nature's slow chemistry at work. Corrosion teaches us how reactive different metals are and why protecting them is so important.